Hello, I am Dr. Srutishrabha Bharali and I welcome you to this lecture video on input, output and conditional statements, which is a part of the online course on open source software for academia. In this video lecture, we will take a deep dive into the foundational concepts of Python programming, focusing primarily on input and output operations. In this video, you will learn how to use different techniques for reading input from users and displaying output in Python, including the use of input and print functions. We will guide you through practical examples that demonstrate how to take user input through the keyboard and format the output to meet specific requirements, such as including labels, aligning text, or formatting numbers and strings. Beyond input and output, this lecture also explores one of the most crucial elements in programming, that is, conditional statements. You will be introduced to various control flow structures that help make decisions in a program, including if else, if else, and nested if statements. This will be explained through step-by-step examples that show how Python evaluates conditions and executes different blocks of code based on whether conditions are true or false. In addition, we will introduce the match statement, a powerful feature in Python that allows for pattern matching, making it easier to handle multiple conditions in a more organized and readable way. Through practical demonstrations, you will see how match can be used as an alternative to lengthy chains of if-else-if statements. By the end of this lecture, you will have a solid understanding of how to work with input-output and apply conditional statements in Python programming. But before we do that, let me define what we mean by input-output. The data given to the computer is called input, and the results returned by the computer is called output. The computer takes and processes the input to produce the result as output. Python provides some statements to provide input to the computer known as input statements. Similarly, Python provides statements to display the output known as output statements. Let us look at the output statements first. The print function is used to display the output. This function is used to display strings, variables, objects, and formatted strings. Let us look at the syntax of the print function. The print function has various attributes like object, separator, end, file, and flush. Let us look at the attributes. The object represents any object. The sep or separator is an optional attribute which is used to specify how to separate the objects if there is more than one. The default is space. Another attribute is end, which is again optional. This is used to specify what to print at the end, and the default option is new line. The file is another attribute in the print function, which is again optional. An object with a write method. The default is sys.stdout. The flush is again another optional attribute. A boolean specifying if the output is flushed, that is true, or buffered, that is false. The default here is false. Let us now look at few examples. Here we can see that the object to print function is welcome to MOOC on open source software for academia, which is displayed as the output on the screen. We can see here that when the string is passed to the print function, the string is displayed as it is. In Python, both single quotes and double quotes can be used interchangeably to define string values within the print function. This flexibility allows programmers to choose either type of quotation mark based on their preference or the specific needs of the string. For instance, if a string contains double quotes inside it, using single quotes to enclose the string can help avoid syntax errors and vice versa. Therefore, the same print statement can be written using single quotes instead of double quotes without affecting the output. For example, the same example can be used using single quotes. Here we can see that when we have given the same input to the print functions, once using single quotes and once using double quotes, we get the same output. Escape sequence characters can also be used within the print function to control the formatting of the output. These special characters begin with a backslash and are followed by a specific letter. For instance, /n is used to insert a line break, causing the text that follows to appear on the next line. Similarly, /t adds a horizontal tab space, which helps in aligning the output neatly or adding indentation. In this example, we observe that using /n in the print statement moves the text following it to a new line. Likewise, using /t in the print statement inserts a tab space before the text that comes after it. To escape the effect of escape sequence characters, we can simply add one more backslash before the escape sequence character. We can see here that adding two backslashes before t displays /t and adding two slash before n displays /n in this example. Let us now look on how we can print variables using the print function. The print function in Python is not limited to displaying plain text. It is also commonly used to display the values stored in variables. This feature is particularly useful when we want to check the value of a variable at a certain point in our program or when we want to display the results to the user. In this example, the variable a is assigned the value 5. When the print a statement is executed, it outputs the value which is stored in the variable a, which is 5. Let us look at another example where we assign values to two different variables and then display their values using the print function. In the following code, we assign the value 5 to variable a and the value 10 to variable b. And then we print both these variables together. The print function displays both values separated by a space by default, demonstrating how multiple variables can be printed in a single statement. Let us now look at how we can use the separator attribute in the print function. In the previous example, when multiple values were printed using the print function, they were separated by a single space by default. However, Python provides a flexible way to customize this separator using the sep parameter in the print function. The sep, which is a short for separator attribute, allows us to define a custom string that will be placed between the values being printed instead of the default space. This is especially useful when we want to format the output in a specific way, such as when we want to use commas or colons or dashes or any other characters or strings. Let us look at the code here to understand the sep attribute. In each of these print statements, the sep parameter changes how the values a and b are separated in the output. So for example, in the first line, the separator has used a comma. In the second print statement, we have used two colons, and in the third print statement, we have used four dashes. By default, the print function in Python ends its output with a new line character, which means that each call to the print function displays its output on a new line. This can be seen from the example here, where each string is displayed in a different line at the output. However, Python allows us to change this default behavior using the end attribute. The end attribute allows to specify what should be printed at the end of each line instead of the default new line. This is especially useful when we want to print multiple print statements to display their outputs on the same line, or when we want to end a line with a specific character or string, such as a space, a tab, or a custom symbol. Here is an example that demonstrates how the end attribute works. In this code, we can see that the first print ends with a tab character. So the next output starts after the tab space. The second print ends with two spaces, and the third print ends with the string 4 hashes instead of a new line. The final output will be displayed in a single line with the custom separators that has been defined by the end attribute. One of the most common and practical uses of the print function in Python is to combine it with both strings and variables to produce meaningful and readable output. This is especially useful when you want to display a message along with the value of a variable, such as during debugging or when presenting the results to the user. In such cases, the print function can take multiple arguments, such as string messages and variable names, and display them together in a single line. Python automatically adds a space between each argument unless specified otherwise using the sep attribute. In this example, the string the value is printed first, followed by the value stored in the variable a, which is 10. The output produced by the print function in Python can be customized and neatly formatted using a special operator known as the person formatting operator. This operator allows us to embed variables or values directly into a string by specifying placeholders within the string. These placeholders are replaced by actual values at runtime, making the output more readable and professional. The general syntax for using this formatting method is shown here, where we have the print followed by the formatted string and then the percentage symbol followed by the variable list. Within the formatted string, special format specifiers are used to indicate the type of data that is being inserted. Some commonly used format specifiers include %d or %i for inserting integers, percentage %s for inserting string values, and percentage %f for inserting floating point numbers. These specifiers act as placeholders that are replaced by the corresponding values from the variable list. Let us look at an example to understand how this works. Here we can see that the name, age and CGPA are printed on the screen. Here we have to note that when we are using %f, the default output includes 6 decimal spaces. So even though we have given the output to CGPA as 4.9, the output was displayed as 4.9 followed by 5 zeros. The number of digits displayed after the decimal point can be customized if needed. For example, if we use %6.2f, then the float value is displayed in 6 spaces, and within the spaces, a decimal point and next 2 fraction digits are included. Similarly, if we use %.4f, then the float value is displayed with 4 fraction digits after the decimal point. Let us consider this example. Here, in the first print statement, %f is used. So, by default, it displays the number with 6 digits after the decimal point. In the second print statement, %6.2f is used, which means that the total minimum width of the output is 6 characters, including digits, decimal point and decimal digits. And only 2 digits are displayed after the decimal point. The third print statement ensures that the value is displayed with exactly 4 digits after the decimal point. In addition to formatting integers, floating point numbers and strings, the percentage operator in Python can also be used to display individual characters using the %c format specifier. The %c specifier is specifically designed to represent a single character. It is commonly used when we want to extract and print specific characters from a string or display a single character value stored in a variable. The example here shows how we can access and display specific characters from a string using indexing along with %c formatting. The variable name holds the string Ramesh Kumar. The name with index 0 refers to the first character in the string, which is R. The name within bracket 7 refers to the 8th character in the string, which is K. The %c format specifier is used twice in the print function, and the corresponding characters are passed as a tuple. In Python, we can use the slicing operator to extract specific portions of a string and display only the desired characters. Slicing allows us to retrieve a substring, which is a sequence of characters taken from the original string, based on specified start and end positions. We have the syntax here where it retrieves characters starting from the start index up to but not including the end index. This technique is useful when we want to extract a part of a name, a word, or any segment of a longer string. For example, name, where the starting index is 0 and the end index is 5, will give us the 0 to the 5th characters from the variable name. This example shows that the print statement will display the output for the sliced portion of the string, which is the substring Ramesh. In Python, when working with formatted strings, we can utilize replacement fields to dynamically insert values into a string. These replacement fields are indicated by a pair of curly braces. Inside these braces, we can specify either names or indexes which determine the position and order in which the corresponding values will be inserted into the string. The formatted string is followed by the format method, which is used to supply the actual values that will replace the placeholders within the string. This method takes the values in the order they should appear and matches them with the corresponding replacement fields. The general syntax for using the format method with replacement fields is given here, where we can see that the format string with replacement fields is followed by the format method. Let us look at the example here where we display a single name and an age using index-based replacement fields. In this example, 0 within curly braces refers to the first value which was provided to the format method, which is name, and 1 within curly braces refers to the second value, which is age. Let us now look at how we can take input from the keyboard in Python using input statements. The input function takes a value from the keyboard of the computer and returns it as a string. In the syntax for the input function, we have the parameter to input, which is a prompt string that prints out on the screen. And also, it is used for prompting the user on what they are supposed to type as input. Let us look at some examples to understand the input function. In this example, on the left hand side, we can see that it will be better to display a message to the user so that the user understands what to enter. This can be achieved by writing a prompt message within the input function. We can see that in the example on the right hand side, we have used the prompt message, enter the name of your city. The input function can also be used to accept numbers. This can be done by converting the value of variable into int or float. We can use the int or float function before the input function to accept either an integer or a floating point number. In this example, we can see that the user gives the input 58 when prompted to enter a number, which is then converted to integer using the int function and stored in the variable num1, which is later displayed on the screen. Similarly, to accept a floating point value, we can use the float function along with the input function. In this example, we can see that the user gives the input 987.65 when prompted to enter a floating point number, which is then converted to float and stored in the variable num2. The value stored in num2 is then later displayed on the screen using the print function. Let us look at few more examples using the input function. Let us look at this program which is used to input two integer numbers and display both the numbers. In this program, the user is prompted to enter two numbers. Each input is converted to an integer using int function and stored in num1 and num2 variables. The program then displays both numbers using the print function. Next, let us look at another Python program which takes two integers and displays the sum and product of those two values. In this example, the program asks the user to input two numbers, which are then converted to integers and stored in the variables num1 and num2. It calculates the sum of the two numbers and stores it in the variable sum. It also calculates the product of the two numbers and stores it in the variable prod. Finally, it prints both the sum and the product using the print function. Next, let us look at command line arguments. In Python, we can also provide input values such as two numbers at the time of running of the program. These values passed to the program from the outside are known as command line arguments. They allow us to interact with the program through the command line or terminal by supplying inputs directly when launching the program. Command line arguments are automatically made available to the program through a special list named as arg or argv, which is a part of the sys module in Python. This means that to work with command line arguments, we must first import the sys module at the beginning of our program using the line import sys. The argv list stores all command line arguments as strings, regardless of whether they represent numbers, text, or other data types. The list follows a specific structure. argv0 always contains the name of the Python script that is being executed. argv1 contains the first argument passed to the script. argv2 contains the second argument, and so on. For example, we will try to find the summation and product of the two integers using command line arguments. Let us look at the modified program first. This program begins by importing the sys module to access command line arguments. It uses the len function to count how many arguments were passed and displays the total command line arguments. Then it adds and multiplies the second and third command line arguments after converting them to integers. The results are stored in the variable sum for the summation and the variable prod for the product. Finally, it prints both the sum and the product of the two numbers. We can run the program by using the syntax below, which is Python program name argument1, argument2, and so on. Since our program is named comline.py and requires two arguments, so we will provide the code Python comline.py followed by 3 and 4. This means that we have provided the arguments 3 and 4 during runtime. The first output displays the total number of command line arguments, which is 3. First for the program name, second for the input 3, and third for the input 4. The second and third output gives the sum and the product of the two integers that were provided during runtime. Let us now look at the next section of the video, which is on control statements. In most cases, the execution of a program follows a sequential flow, meaning that the statements are executed one after another in the exact order in which they appear in the code. However, real-world problems often require more complex logic, where certain parts of the code may need to be executed conditionally, repeated multiple times, or skipped entirely based on some specific criteria. To achieve such flexibility in program execution, we use what are known as control statements. Control statements are statements that help to control or change the flow of program execution. Some of the common control statements that are available in Python and that we are going to discuss in this video lecture are the if statement, if else statement, if elif else statement, and match statements. Control statements are essential for writing dynamic, logical, and interactive programs. Conditional statements involving decision making are especially useful when handling complex scenarios where the program's response needs to change based on user input, variables values, or specific conditions. Let us look at the first conditional statement, which is the if statement. The if statement is used to execute one or more statements depending on whether a condition is true or false. This type of statement is used in programming to determine whether a specific block of code should be executed or not, based on whether a given condition evaluates to true or false. In other words, it allows the program to make decisions during execution. If the condition specified is true, then one or more statements within the block are executed. However, if the condition is false, those statements are skipped and the program moves on to the next part of the code. The syntax of the if statement is shown here. The condition is tested. If the condition is true, then the statements after the colon are executed. There can be one or more statements after the colon. If the condition is false, then the statements after the colon are not executed. Let us look at an example. In the example here, we can see that the first line assigns the integer value 1 to the variable named as num. The second line checks whether the value of num is equal to 1 using the if condition. The third line will be executed only if the if condition, which is num equal to 1, is true. In our example, since num is actually 1, this condition is true, so the program prints the string 1 as it can be seen in the output. In Python, it is also possible to write multiple statements that are executed together as a group when a particular condition is true. This group of statements is known as a suite. A suite represents a block of code that is associated with a control statement such as if, for, or while. To define a suite properly in Python, indentation is crucial. All the statements that belong to the suite must be indented consistently to indicate that they are part of the same block. By default, Python uses 4 spaces for each level of indentation. Let us look at an example to understand the if statement. In this example, all the statements following the colon are indented at the same level, indicating that they belong to the same suite or block of code associated with the if statement. This consistent indentation tells Python that these lines should be executed together. If the condition in the if statement evaluates to true. Since the condition is indeed true in this case, the program proceeds to execute all three statements within the suite, resulting in all three lines being printed as output. The if-else statement in Python is a fundamental control structure used to perform decision making within a program. It allows the program to choose between two distinct blocks of code depending on whether a given condition evaluates to true or false. We can see the syntax here. When the specified condition in the syntax is true, the program executes the first group of statements that immediately follow the colon, which is the statements 1. However, if the condition is false, the program skips the if block and instead executes the group of statements under the else clause, which is statements 2. This structure ensures that one of the two blocks will always be executed, but never both. As in the case of if statement, here also proper indentation is required to define both the blocks under if and else. Let us now look at an example. In the program here, the first line is a comment and the second line prompts the user to enter a number which is then stored in the variable num. The third line checks whether the entered number is even. If the condition num modulus of 2 is equal to 0 evaluates to true, it means that the number is divisible by 2 and the program will execute the statement inside the if block. On the other hand, if the condition evaluates to false, meaning the number is not divisible by 2, the program will skip the if block and instead execute the statement inside the else block. Here in the output, we can see that in the first case, the number 7 is an odd number and hence the condition will be false. So, the statement within else block is displayed. However, in the second case, the number 4 is an even number and hence the condition is true, so the statement inside the if block is displayed. Let us now look at the if-elif else statement. This statement in Python is used when we want to evaluate multiple conditions and execute a specific block of code based on which condition is true. This structure is particularly useful when there are more than two possible outcomes and each one requires a different set of instructions to be executed. The syntax for the if, elif, else statements are displayed here on this slide. Let us now try to understand the syntax. Unlike the simple if-else structure that handles only two possibilities, the if-elif-else chain allows us to test several conditions in sequence. Python evaluates these conditions from the top to the bottom. And as soon as it finds a condition that is true, it executes the corresponding block of code and skips the rest of the conditions and their associated blocks. For example, when condition 1 is true, then the statements 1 are executed. If condition 1 is false, then condition 2 is evaluated. If condition 2 is true, then statements 2 are executed. When condition 2 is false, then condition 3 is evaluated and so on. When all the conditions are evaluated and are false, then the control enters the else suite to execute the statements n in the else suite. Also, the else clause is optional here, but it is useful as a fallback in case none of the conditions are met. It is important to note here that only one block of code is executed in this structure, which is the first one with a condition that evaluates to true. Also, proper indentation is very important for defining all of the code blocks clearly. Let us look at a program to understand this. The first line in this program is a comment, and the second line prompts the user to enter their age. The program then checks if the person's age is 60 or more. If this is true, the program will print senior citizen and skip the rest of the conditions. If the first condition is false, then the program will check if the age is greater than 18 and less than 60. If this condition is true, then the program will print adult. If the second condition is also false, then the else block is executed, which will print not an adult on the screen. We can see all three cases are shown in this output. First, when we entered the age as 45, the elif statements are executed. In the second case, when 67 is entered, the statements under if are executed. In the third case, the else statements are executed since both the if statements and the elif statement conditions are false. In Python, it is possible to place one if-else statement inside another if, elif or else block. This concept is known as nested if statements. Nesting allows us to perform more complex decision making where a new condition is evaluated only if a previous condition is true. Nested if statements are useful when the outcome depends on multiple levels of conditions. For example, we may want to check a second condition only after the first one has been satisfied. Let us understand the syntax. The nested if-else structure allows a program to make multiple levels of decisions where one condition depends on the outcome of another. The program first evaluates condition 1. If condition 1 is true, it enters the outer if block. Inside this block, there is another if-else structure, often referred to as the inner block. Once the program enters the outer if block, it checks condition 2. If condition true is also true, it executes statements 1 that is inside the inner if block. If condition 2 is false, then it moves to the inner else block and executes the statements 2. If the initial outer condition, which was condition 1, is not true, then the program skips the entire inner if else structure and jumps to the outer else block. It then executes the statements 3. Let us look at an example. The program finds the greatest of three integer numbers. The program begins by asking the user to enter three numbers, and these values are to be stored in the variables num1, num2 and num3. In the output for this program, we can see that the values for num1, num2 and num3 are given as 11, 45 and 23. The program first checks if num1 is greater than num2. Since num1 greater than num2 is false for our example. So now the program checks if num2 is greater than num3. Since this condition is true as 45 is greater than 23, so num2 is greater than both num1 and num3. That is 45 is greater than 11 and 23. The match statement is a modern feature in Python which has been introduced in the Python version 3.10. The match statement in Python is used for pattern matching, which helps in selecting and executing one block of code from multiple possible options, depending on the value of an expression. It is similar in purpose to the switch case statement found in other programming languages like C. The advantage of the match statement is that it offers a clean and readable way to handle multiple conditional branches based on the value of a single variable or expression. Let us look at the syntax which is displayed in this slide. Let us try to understand the syntax. The expression following the match keyword is evaluated only once. The result of this expression is then compared against the values provided in each case. If the value of the expression matches any of the case values, the corresponding block of code is then executed. Once a matching case is found and its code is executed, the match statement completes its operation. If none of the case values match and a case underscore is provided as a default, then the code under that case will run. Let us look at an example to understand the working of match statements. This program is designed to display the name of the day of the week based on the number entered by the user. The user provides an input, usually an integer, for example from 1 to 7, which represents the days from Monday to Sunday. The program uses the match statement to evaluate the user input. This input is compared against each defined case within the match block. When the value entered by the user matches one of the cases, the statements associated with that particular case are executed. For instance, in the first case of the output, the user enters the number 3. The program checks each case until it finds case 3 and then executes the code block that is under that case, such as printing Wednesday. Similarly, in the second case, since none of the earlier cases had been matched, so the statements in the default case is executed. Let us take a moment to assess your understanding with a couple of quick multiple choice questions. This will help you review and reinforce what we have covered in this tutorial. Here is the first question. What is the main purpose of the print function in Python? Take a moment to think about your answer. The correct answer is option C, to display output on the screen. Here is the next question. What is the output of the code displayed on the screen? Take a moment to think about your answer. The correct answer is option B. Here is the next question. What will be the output of the following command if x is equal to 5 and y is equal to 10? Take a moment to think about your answer. The correct answer is option B, that y is greater. Here is the last question. What type of data does input function return? Take a moment to think about your answer. The correct answer is option C, string. This lecture video provided a thorough overview of input and output operations in Python, demonstrating various methods for receiving user input and displaying output effectively. It also covered conditional statements such as if else, if else, and nested if statements explained through multiple examples. Additionally, the lecture introduced the use of the match statement with practical examples. Thank you for watching this video.